sklearn, Impute, Iterative Imputer. A deep dive. The Iterative Imputer in scikit-learn is a powerful tool for handling missing values in your dataset. It goes beyond simple imputation strategies like mean-median replacement by leveraging relationships between features to estimate the missing values. Here's a detailed breakdown. 1. The concept. Iterative imputation. This method works by iteratively imputing missing values in each feature using a predictive model trained on the other features. Model-based. It relies on a specified model like a decision tree, Bayesian ridge, or k-nearest neighbors to predict the missing values. Cycle-wise imputation. The imputer iterates through each feature with missing values, using the predicted values from the previous iteration to improve the next round of predictions. This process continues until convergence, meaning the imputed values become stable. 2. Key parameters. Estimator. The model used for prediction. This is a crucial parameter. You can choose. Default uses Bayesian ridge regression. KNN uses k-nearest neighbors. RF uses random forest. Or your own custom estimator must support fit and predict. Missing values specifies the value representing missing data. Default is np.none. Sample posterior. When true, the imputer draws samples from the predictive distribution for each missing value. This provides more realistic estimates, especially for continuous features. N-nearest features only applicable when using KNN estimator. Determines the number of nearest neighbors to consider for prediction. Initial strategy. The initial strategy to fill missing values before starting the iterative process. Options include mean, default, median, most frequent, constant, maxiter, maximum number of imputation iterations, tolerance for convergence. Verbose controls the level of output during the imputation process. 3. Advantages. Handles complex relationships. Can capture nonlinear relationships between features. Unlike simpler imputation methods. Improved accuracy by utilizing predictive models. It often leads to more accurate imputed values. Flexibility allows you to choose a suitable model based on the nature of your data. 4. Disadvantages. Computational cost. The iterative process can be computationally intensive, especially for large datasets. Potential for overfitting. If the model overfits the data, the imputed values might be unreliable. Data requirements. The method requires a sufficient amount of complete data for the model to learn relationships effectively. 5. When to use. Complex datasets with strong relationships between features, especially those involving nonlinear interactions. High proportion of missing values when a significant portion of the data is missing. Seeking accurate imputation when you require the most accurate imputation possible. 6. Example. Python. From sklearn, experimental import enable iterative imputer. From sklearn, impute import iterative imputer. From sklearn, linear model import Bayesian ridge. Create an imputer with a Bayesian ridge estimator. Imputer iterative imputer estimator Bayesian ridge. Random state 0. Fit the imputer to your data. Imputer, fit data. Transform the data with missing values filled. Transformed data imputer. Transform data. 7. YAML configuration explanation. YAML. Imputer. Estimator model used for imputation. See options above. Missing values. Value representing missing data, e.g. np.none. Sample posterior. Draw samples from the predictive distribution. N nearest features. Number of nearest neighbors only for KNN estimator. Initial strategy to fill missing values. Maxiter, maximum number of iterations. Tolerance for convergence. verbose output level during imputation. Conclusion. Iterative Imputer is a sophisticated tool for imputing missing values in your data. Its power lies in its ability to leverage predictive models to capture complex relationships and achieve more accurate results. However, it's crucial to consider its computational costs and potential overfitting risks when applying it. By carefully choosing parameters and understanding its strengths and limitations, you can effectively utilize Iterative Imputer to handle missing values in your datasets.